All right, good morning, everybody. Welcome to a fine Monday morning. It's sort of cloudy outside. Some of you probably haven't even looked outside yet. It's a little cloudy out, a little chilly. Hope everybody had a good weekend. First thing we're going to approach today or look at today is your homework from Friday. First off, is anybody having any issues hearing me? But nobody's saying anything. Hopefully you can hear me. Hopefully everything's going well. If we take a look at your homework from Friday, okay, your homework from Friday, in problem number 2, you have an average 1-year-old, both gender, and the average for 1-year-old, both genders is 29 inches tall. Random sample of 30 1-year-olds in a large daycare franchise result in the following height. At an alpha value of 0.05, can it be concluded the average height differs from the 29 inches? So if we take a look at problem number 2, we have the null and alternate hypothesis. And if you not have done this, please, let's do it. Okay, we're stating our null and our alternate hypothesis. You have 31-year-olds, daycares, and you have a bunch of data points there. Can it be concluded the average height differs from 29 inches? Okay, so we have the word differs in there, which should indicate whether we have a what our null and alternate hypothesis should look like. When we take a look at the null and alternate hypothesis, Vivi, what's your alternate hypothesis here? Yeah, mu is not equal to 29, which means our null hypothesis is mu is going to equal 29. Now, the next thing we do, we look at our data values. We have to have a mean, a standard deviation. We had a sample size of 30. We have an alpha value of 0.05. If we take a look at our bell-shaped curve, and we look at our bell-shaped curve, if we have equal to, not equal to, is this going to be a one-tail test or a two-tail test? Test, would this be a one-tail test or a two-tail test?
Two-tail.
Two-tail. So we will get both of our tails in here. We get our two tails in there. The next thing we need to find is our critical values. So we go to our t-table. On our t-table, we have a two-tail test. We have two-tail. We have an alpha value of 0.05. So to find our critical values, we take our t-table down to the bottom, and we have a critical value of 1.960. So these are our critical values. 1.960 and a 1.960. This will be negative, and that one will be positive. We had to find a test value, which is x bar minus mu divided by standard deviation divided by the square root of n. The problem we run into is we don't know our x bar and we don't know our standard deviation. But we have a bunch of data points. Now, if you remember back to what our calculator will do for us. Okay, let's look at our calculator. Pull your calculator out. If we go to our stat button and we go to edit, Oh, I see I got a bunch of data values in there, and I don't want all those data values. So if you remember back to what we did, we hit a second button and our plus sign, and we hit option 4. We clear all lists and hit enter. Now if I go to my stat button and go to edit, my lists have been cleared. And that's what I want. So if you've not done that, please do that. Once again, go to second and the plus sign. And option number 4 says clear all lists. So you're going to clear all lists, hit enter, and it will just clear all your lists for you. Now we go back to our stat button, and we want to edit our lists. So in our list 1, I'm going to enter all these values. 25, 32, 35, 25, 30, 26.5, 26, 25.5, 29.5, 32, 30, 28.5, 30, 32, 28, 31.5, 29, 29.5, 30, 34, 29, 32, 27, 28, 33, 28, 27, 32, 29, and 29.5. Hopefully I entered them in all correctly. If I take a look, I got my L, what I'm at now is a 31, which means I've entered in 30 values. I'll give you another minute to get all those values in. Your calculator is a very nice tool for you. It will do a lot of work for you. It will do a lot of work for you if you let it. So I'm going to quit out of this now. So I come back to my main screen. I'm going to hit stat. Here, hit my stat button again. I'm going to calculate. Now what we have here is we have one variable statistics. Now the nice thing about your calculator is it will do all these calculations for you. I want to do the one variable statistics, so hit enter. So one variable statistics pops up, hit enter one more time. And what happens is it gives us all of our data values. It gives us our mean, it gives us our standard deviation, it gives us a bunch of different values. It will actually give you, if you continue to go down, max, your lower quartile, your median, your upper quartile, your maximum. So it will give you all the statistical values that we did at the beginning of the year. Our main thing is we want to get the mean and the standard deviation. Now this is a sample of 30 kids, so we want the sample standard deviation, so we want S. So that's 2.61. We have 29.45 for our mean. Our standard deviation, our S is 2.61. So it gives us our values that we can work with. our next step. Now, most of these problems will give you these actual values. This one did not give you the values, so I want to make sure we go through this so everybody is in tune to using your calculator. So we can substitute our values in now. Our x bar is 29.45. Our mean is 29, our accepted value. Our standard deviation is 2.61, and then we have the square root of 30. Now you're going to want to quantify both of these. And once again, going into the calculator, we had 29.45, so I'm going to quantify 29.45 minus 29 divided by 2.6, parenthesis, 2.61 divided by the square root of 30. And parenthesis, and I have to put two of them there because my parenthesis, or my calculator put a parenthesis in there. Now, some of you have to hit your right button and pull out of the radical, which is fine. So we hit enter, and we get a test value of 1.17. So we have a test value of 1.17. And if we take a look, here's our 0. 1.17 will be somewhere in this range. Now this is a non-critical region. And these two regions are your critical regions. And going back to our notes from last week, if we're in a non-critical region, we fail to reject the null hypothesis. If we're in a critical region, we reject the null hypothesis. So here we fail to reject. And here we reject and reject. So we fall into a non-rejection region. So at this time, we fail to reject the null hypothesis. Of the mean height. Of 29 inches. So that is a summary of your findings. What I need to see on this type of problem, I don't need to see, I just need you to pull this stuff off the calculator and write it down. And inevitably, when you have a lot of data values here, you might make a little bit of a mistake, which I could have also, because if I look at my answers, I got a 29.78 and a 2.66 for standard deviation. You just need to show me that you have something just a little bit different there. And if you have this process through this whole thing correct, if this process is still correct here, okay, you'll still get a correct solution. Any other questions about the z-test? All right, we're going to take a look at a different value that will allow us to be able to reject or fail to reject a null hypothesis. If we take a look at the second one here, average salary for public school teachers. Average salary for public school teachers for a specific year was reported as $39,385. Random sample 50 public school teachers in a particular state had a mean of 41,680. Standard deviation of 59,75. Is there sufficient evidence at an alpha value of 0.05? The level can be concluded the mean salary differs from the 39,385. Okay, once again, we have the word differs in there. We have the word differs in there, which helps our null and alternate hypothesis. Go ahead and write your null and alternate hypothesis. Tyler Ramsire, what would be your null and your alternate? Let's start with let's do your alternate hypothesis. What would be your alternate hypothesis here?
Mu is not equal to 50.
Not the 50 differs from the 39,385. 39,385 does not equal to the 39,385, which means this is equal to 39,385. Okay, so that's our mu value. We have an x bar, which is 41,680. We have a standard deviation of 59,75. We have a sample size of 50, and we have an alpha value of 0.05. So if we draw our bell-shaped curve, is this going to be a one-tail or a two-tail test? Owen, would this be a one-tail or two-tail?
Two-tail.
Two-tail? So we're going to get our two tails in there. We go to our t-table. Go to our t-table. We have a two-tail test. We have an alpha value of 0.05. We drop it all the way to the bottom. Our critical values, Allie Jackson, what will be our critical values?
The critical values, is that on the T?
Yep, the t-table. Drop it all the way to the bottom. You have an alpha value of 0.05. Two-tail test.
1.96.
1.96. We now do a z-test, which is x bar minus mu divided by standard deviation, square root of n. So you throw in your values, 41,680 minus the 39,385. Standard deviation, 59,75. Then square root of 50. Make sure you quantify. And once again, some of your calculators will throw a parenthesis there, so you have a parenthesis to end the radical, and then you have to throw a set double parenthesis at the end. Other ones, you have to use your right arrow to pull out of the radical. So calculate your z-test value. Sarah, what do you give for a test value?
2.72.
2.72. Yeah, that's what I got too. So if we take a look, 2.72 throws us out here. This is non-critical. This is critical. Critical. So we fall ourselves or find ourselves into a critical region now. So if we're in a critical region, we can now reject the null hypothesis of the mean salary of 39,385. So we can reject that, and we can then set, if we wanted to, set a value. We can have a different study and get a bigger sample size and get an actual value. Or we can use the 41,680 and saying the mean salary for that state is 41,680 rather than the 39,385. Once again, just re-emphasis of a z-test and how we deal with a z-test and a z-value. Another way of being able to reject or fail to reject a null hypothesis is by using a p-value. When dealing with a p-value, it's the area under a standard normal distribution curve representing the probability of a particular sample statistic. The area under a standard normal distribution curve representing the probability of a particular sample statistic, which is what we are dealing with here. The p-value is the area outside the area arrived at from the z-score. The area outside the area arrived at from the z-score. If you go back to what we did with respect to a z-score, we have a bell-shaped curve. We calculated the z-score. Here's our 0, and this was our table value. This area that we calculated was our table value. It was the area between 0 and a z-score. What the p-score is And we've calculated with this, we just never called it the p-score. This here is the p-value. This area outside the area that we came up with respect to our z-value. This is the p-value. The p-value is a little bit more work, it's a little bit more extensive. But we'll also take a look at our calculator. How we calculate the p-value? You calculate a z-score, which we did. We calculated a z-test score, 2.72. For example, we just did up above, our z-test was 2.72. You go to your z-table and determine an area. So if we look at the bottom here, we have 2.72. We go to our z-table. Now, I'm not going to ask you to do this. I'll just find the value here. 2.72 from our z-table is 4.4967. So our table value for this particular example is 2.72, table value 0.4967. Step 3, subtract the area from 0.5. So we have 0.5 minus the 0.4967, which gives us 0.0033. If you have a one-tailed test, this is your p-value. If this is a two-tailed test, you multiply by 2. Well, this is a two-tailed test, so we're going to take 0.0033 times 2, 0.0066. If this was a one-tailed test, this is your p-value. This is a two-tailed test, you multiply by 2, because we have both the areas. That is the reason why. We have a two-tailed test. If you look at a two-tailed test, you have 0.0033 here, you have a 0.0033 here. If the p-value is less than the alpha value, you reject the null hypothesis. If the p-value is greater than the alpha value, you fail to reject the null hypothesis. So if the p-value is less than the alpha value, you reject the null hypothesis. p-value is greater than the alpha value, you fail to reject the null hypothesis. Well, if we take a look at this, our p-value comes down to 0.0066. And this is less than the alpha value. 0.0066 is less than 0.05. So we can reject the null hypothesis. Is everybody caught up so I can move on? Do you need me to wait another second? Speak up, please, if you're... Because now we're going to take a look at our calculator. Once again, I told you your calculator is a very, very nice tool to have. Now, I'm not going to ask you to go through and calculate a p-value in this manner, because your calculator will do this for you. So let's go back to our calculator. Let's go to statistics. Once again, you have three headings there. We use the edit to add our lists. We have our calculator that will calculate our one variable statistic. The last category over here is a test. So I want you to go over to tests. And what you see there is you see a z-test, a t-test. Well, we're going to deal with a z-test here. So hit enter. Now you have two different things that you can be dealing with here. You can deal with data values, which it gets pulled from your table, and we'll look at that in a second. Or we can take a look at statistics that we're going to add in. We're going to add in the statistics. Okay, so if this is highlighted there, data values, you want to use your right arrow and go over to statistics and hit enter. Our mu, okay, is the 39,385. So we enter in 39,385 and hit enter. Our standard deviation is 5975. So I'm going to add in the 5975 and hit enter. Our sample mean is 41,680 and hit enter. Our sample size is 50. Now, we are looking at the next line is going to be your alternate hypothesis. Okay, this is going to be your alternate hypothesis. What we have in our alternate hypothesis is not equal to. So we want to hit enter on that to make sure that's highlighted. If this one's highlighted over here, I use my right arrow and highlight the not equal to. This is your alternate hypothesis. Now let's go down to the bottom and let's draw. Hit enter. And what you get is a nice little bell-shaped curve. What you also get is your z-value that we calculated for this, 2.72. And also your p-value, 0.0066. Now, if you're going to do your z-test value, that's fine. Just, you can utilize this as your check. What it also gives us, it gives us our bell-shaped curve, and you don't see it here, but you have a little bit of highlights to the very end. Once again, it's a nice tool to have. Just for giggles here, let's go back and let's look at the data one that we did. The first problem we did. We'll show you how nice this calculator is for you. Let's go back to stats. Okay, we've already entered into list number 1 all of our data values. Let's go over to test. Let's go to z-test. Now what I want to highlight is I want to highlight the data values. So highlight data and enter. Our mu naught in problem number 2 we did on our homework is 29. Our standard deviation that we calculated was 2.61. We're looking at list 1. So we have an L1 there. That's the list that we're pulling out. If we had a different list, we can change our list to L2. But we're using L1. Once again, we still have our mu is not equal to. And let's go to calculate. And what you'll see is you'll see a z value, 0.9443. I might have botched that up. And a p-value of 0.345. I might have entered in a data value incorrectly. But it gives us, if you see, you have this area here shaded in, and this area shaded in. This signifies your z value that you have. Once again, your calculator will do a lot of stuff for you. Utilize it. Okay, what I want to see is I want to see data values down now. I want to see as much work as possible. Okay, your first part of your homework assignment is going to go back to your homework that you did for today. And all I want you to do is go back and calculate a p-value for each one of those problems. Calculate a p-value so you can get used to what your calculator will do for you. The second part of your homework is if you go to your next page of your notes. Okay, we're not going to do the back side of these notes. We're just going to do the next page of the notes. So we have, it should look like this. Should be a t-test at the very top. 7.4 t-test hypothesis testing. And once again, if you need to go back, this whole lesson will be captured. It will be screencastified and captured, and it will be posted on Google Classroom. The second part of this lesson today is dealing with a t-test. We can also deal with a t-test. And your t-test is a statistical test for a mean of population, and is used when the population is normally or approximately normally distributed, Sigma may not be known, standard deviation may be unknown, and your n value is less than 30. So once again, we're dealing with when the sample size is less than 30, we still want to be able to do a hypothesis test. We want to do a hypothesis test, but our sample size is less than 30. This is very, very similar to a z-test. We still deal with a degree of freedom. Max, how do we find the degree of freedom again?
The sample size minus 1.
There you go. N minus 1. So we have n minus 1. And this is the key statement. The traditional t-test is the same as a z-test, except for the population is smaller than 30. Smaller than 30. Once again, we'll still be utilizing our t-table. What changes in this is your critical values is dependent on your degree of freedom. You have your degree of freedom. And your alpha value. So no longer will we drop all the way down to the bottom for the z value. We have to look at our critical values by looking at our degree of freedom. So it's basically going to be the same, except for how we find a critical value. All right, we'll do a one-tailed test here in this one. A study found that the average stopping distance of a school bus traveling 50 miles per hour is 264 feet. And that's a safely thing. I understand if you run into something, you'll stop immediately. But if you safely stop going 50 miles an hour for a school bus, it takes 264 feet, which is almost a football field. A group of automotive engineers decided to conduct a study for 20 buses. The average stopping distance was 262.3. Standard deviation was 3 feet. Tesla claimed the average stopping distance of the company's buses is actually less than the 264. So once again, here's our accepted value. This is the accepted value. The engineers at this busing company says it's going to be less than that. That's what they hope is true. That it's less than. So we write our null and alternate hypothesis. Whoopsie. If we look at the alternate hypothesis, Trevor, what would you write down as your alternate hypothesis?
Mu is less than 264.
Yep, mu is less than 264, which means the null hypothesis, what would be our null hypothesis? Callie, what would be our null hypothesis?
Mu is greater than or equal to 264.
All right. So we now look at our information. We have an X bar of 262.3. We have a standard deviation of 3. We have a sample of 20, which gives us a degree of freedom of 19. And we have an alpha value of 0.01. Let's get our bell-shaped curve in there. Tyler Nussbaum. Tyler Nussbaum, would this be a one-tail or two-tail test? One-tail test, would it be left or right? Look at your alternate hypothesis. Look at your alternate hypothesis. Which direction is your alternate hypothesis showing? What's your arrow showing to? Is it showing left or right? Left. So this is going to be one tail. And it's going to be left. So I'm going to throw my critical value over here on my left-hand side. Because I have a one tail and it's going to be left. So now we go find a critical value. We have a degree of freedom of 19. We have an alpha value of 0.01, and we have a one-tail test. So along the top, I'm looking at my one-tail test. I go over to 0.01. Now I'm going to drop this all the way down to just my degree of freedom of 19. So we have a degree of freedom of 19, alpha value 0.01, and a one-tail test. Emily, what is your critical value?
$2.539.
2.539. And once again, just showing we have a one-tail test, alpha value of 0.01, and we're going to drop this all the way down to a degree of freedom of 19, which gives us our 2.539. Now, since it's on my left-hand side, it's a left-hand test, I have to throw a negative with that. My test value is going to be the same. We have x bar minus mu divided by standard deviation, square root of n. So your z-test and your t-test are going to be the exact same way of calculating. So let's put in our numbers. We have 2.623 minus 264. Get your quantity there, divided by standard deviation, which is quantity 3, divided by the square root of 20. Once again, this is a square root of your sample size, not your standard deviation. I'm sorry, your degree of freedom. So calculate your test value. I'm sorry, that should be 262.3. Sorry about that. 262.3. There we go. That's a little better. 262.3 divided by 264, or minus 264. Divided by 3, parenthesis 3, by square root of 20. Mitchell, what do you get for a test value?
Negative 2.53.
Negative 2.534. I'm going to take it one more decimal point because this is negative 2.539. Well, here's my zero value here. We are right next to this critical value. This is non-critical. This is critical. So we fall just left or just right of that non-critical value or that critical value. So at this point, we can still not reject the null hypothesis. So we fail to reject null hypothesis of stopping distance of 264 feet. But we are so close. This is where the engineers are going to sit there and go, okay, we're really close. We're going to go back and reevaluate this and restudy this because we still feel our claim is less than 264 is true. But we don't have enough data yet to be able to realize or be able to reject the null hypothesis. Now, we're going to take a look at your calculator one more time. So if we take a look at your calculator one more time here, let's go back to stats again. Let's go back to the test. Now, if you look at option number two is a t-test. So we want to do a t-test. So we're going to go down to the t-test, hit enter. Now what we have here is we have statistics. So we're going to go over to stats. My mu is 264. My sample standard deviation or mean was 262.3. My standard deviation was 3. My sample size was 20. And once again, this next line is the alternate hypothesis. So my alternate hypothesis was less than, so I'm going to go over to my less than button. Let's go down to draw. So let's draw it. And you see the peak is a little bit higher now. We have our t value, our test value, negative 2.534, which we calculated. And our p value comes down to 0.0101. Which is greater than our alpha value of 0.0 or 0.1. Which once again would lead us to failing to reject the null hypothesis. The t-test is the same as the z-test, except for now your critical value you have to find, you have to go to your table. You don't drop to the bottom of your table. That's the only difference. What I want you to do for your homework, once again, you have two things in your homework. Go back to your old tests or your old problems and work on finding the p-value. You know what? Let's not worry about that. This is just what I want you to do for your homework is the next page of your packet. In your next page of your packet, you have the some t-tests. You have some t-tests. Go ahead and calculate the t-value, then also plug it into your calculator and find your check your t-value with your calculator, and then find your p-value. So in the next page of your packet, go through this process here first, calculate a t-value, a test value, and then plug it into your calculator and test your t-value, your test value, and then pull out a p-value also. Solutions, I think I posted the solutions also for the next worksheet. On Wednesday, we'll work on a chi-squared. We'll do a hypothesis testing for the standard deviation. We'll work on that. Another worksheet will be given that will have all of them combined together. Friday is going to be a review day, and next Monday, I may change that. I'll work on that. I may throw one more set of information in testing 2 tests or 2 means on Monday. And then we'll do a review day on Wednesday and then a quiz next Friday, or a chapter test next Friday over the material. Don't think I'm going to be able to get the final in before the semester or before Christmas break. It may be after, I'm sorry. I'm trying, but I'm limited in my number of classes, so I'm trying to push through. We'll see what we can do in trying to push it through. I might be able to make it work. We just have to be, we're going to have to push to get our final in before break. I'll work on that. We have 2 more sets of information to deal with. We have hypothesis testing for standard deviation. We also have a 2-mean hypothesis testing that we have to go through. We might be able to get your final before break. If you have any questions on any of the material that we covered today, feel free to email me. Feel free to stick on here. We got another 5-7 minutes left. You can ask any questions. This is done at 9:10, but I have no more material for you to cover today. Go through the worksheet. Solutions are posted. And once again, work on your calculations, how to calculate your t-test value. Then do a p-value from your calculator if you have access to it. If you don't have access to a calculator, we'll do that for you. That's fine. You do not have to do a p-value to either reject or fail to reject the null hypothesis. I'll leave that up to you. Test value, I like the test value because it shows us numbers on a bell-shaped curve. But a p-value is there if you go to college. Some professors in college may ask you to find the p-value and do everything with respect to the p-value. I don't like that. I like utilizing the z-test and critical values. So once again, hope everybody had a good weekend. Browns won again. There we go, 9-3. Gotta like that. Good to watch. Yeah, Buckeyes won. That's a good thing. Other than that, if you have anything else that you want to stick around for, that would be fine. Other than that, I'm done for today. I will see you on Wednesday. We'll see what we can get through on Wednesday. Questions, once again, stick around the last 5 minutes if you have any questions to ask. Other than that, adios. Out of here. Take care of yourself. Get your work done. See ya.